Chapter 1, Introduction and Fundamentals. What is the digital convergence? The modern technology landscape is no longer a collection of isolated innovations. It is an interconnected ecosystem where artificial intelligence, quantum computing, cloud infrastructure, blockchain, and autonomous vehicles interact in ways that were unimaginable a decade ago. At its core, this convergence is driven by the need to process ever larger volumes of data, automate complex decision-making, and create new value streams that accelerate productivity and solve societal challenges. Think of this ecosystem as a giant, self-learning machine that continuously refines its understanding of the world by ingesting information from sensors, human inputs, and other digital services. By blending computational speed with intelligent patterns, this system is reshaping how businesses operate, how policymakers regulate, and how everyday life unfolds. A brief history. The story began with mechanical computing devices in the 19th century, which paved the way for electronic computers in the mid-20th century. The 1970s introduced the personal computer, and the 1990s brought the first commercial internet. In the 2000s, smartphones and cloud services began to democratize digital access. The mid-2010s saw the rise of large language models, starting with BERT and moving to GPT-3 and 4, while quantum computing experiments turned from theory to laboratory prototypes. Today, these strands converge to power global systems with unprecedented scale and speed. Each milestone built on its predecessor. The same silicon that once powered mainframes now underpins AI accelerators, and the same cloud data centers that host social media also run quantum-enhanced simulations. Core concepts and why it matters. Artificial intelligence and machine learning provide the algorithms that turn raw data into actionable insights. They enable systems to learn from experience without explicit programming. Quantum computing offers a fundamentally different computational paradigm, exploiting superposition and entanglement to solve certain problems exponentially faster than classical computers. Cloud technologies deliver the elastic, on-demand infrastructure that hosts AI models and quantum simulators alike, enabling distributed workloads to run close to data sources and reducing latency. Blockchain and Web3 shift the ownership and transfer of digital assets from centralized authorities to distributed consensus, fostering new business models like decentralized finance. Autonomous vehicles rely on a fusion of AI perception, real-time decision-making, and precise control systems to navigate physical environments. Together, these technologies form a feedback loop. AI accelerates cloud and edge deployments. Quantum breakthroughs enable new AI training algorithms. Blockchain secures data integrity for autonomous systems, and autonomous vehicles generate massive sensor data sets that fuel further AI research. This ecosystem is not just a technical marvel. It has economic, social, and cultural implications that can reshape the very fabric of civilization. Chapter 2, Current State and Advancements. Artificial Intelligence and Machine Learning. The past 2 years have seen the launch of multimodal large language models, such as GPT-4 and its open-source counterparts, that can understand and generate text, images, and code in a single interface. These models have reached 100+ billions of parameters, but the real leap is in training efficiency and data filtering, which have cut carbon emissions from training by 40% compared to earlier models. In healthcare, AI models now predict patient deterioration in real time with 92% accuracy, while in finance, they detect fraudulent transactions faster than human analysts, saving banks billions annually. Researchers are also exploring foundation models that learn across modalities, opening doors for adaptive AI that can reason across text, vision, and speech seamlessly. Quantum computing breakthroughs. In 2023, IBM announced a 433-qubit processor that is poised to demonstrate small-scale quantum advantage, while Google's Sycamore platform now reports noise-resilient algorithms on 54 qubits with a significant reduction in error rates. The most significant theoretical advance is the introduction of surface code error correction protocols that bring practical quantum supremacy within reach for certain optimization problems. By the end of 2024, several startups have begun to offer quantum as a service through hybrid cloud platforms, enabling enterprises to run quantum circuits for chemical simulations, supply chain optimization, and cryptography without owning a quantum machine. Hyperscale cloud and edge. 2024 has witnessed the emergence of 5G-compliant edge centers that bring compute, storage, and networking to just a few meters from the device. Microsoft's Azure Edge Zones and Amazon Web Services outposts together serve over 9,000 cities worldwide, supporting latency-critical apps like remote surgery and augmented reality. Cloud providers are investing heavily in renewable power and carbon-neutral data centers, with Google, AWS, and Azure each announcing that 70% of their global capacity will run on renewable energy by 2026. Multi-cloud strategies are reinforced by open orchestration tools such as HashiCorp Terraform, enabling seamless migration between providers and reducing vendor lock-in. In addition, cloud-native services now include automated machine learning pipelines and quantum simulation runtimes, lowering the barrier for developers to integrate these advanced capabilities. Blockchain and Web3 innovation. Beyond cryptocurrencies, Web3 technologies have reshaped digital ownership with non-fungible tokens, NFTs, transitioning from art to utility tokens, granting real-world access rights in games, real estate, and corporate governance. Decentralized finance platforms have matured. For instance, Compound and Aave now support over $100 billion in lent assets, driven by stablecoin collateralization and algorithmic stablecoins. Layer 2 scaling solutions like Optimistic and zero-knowledge rollups have slashed transaction fees from 10 cents to 1 cent on Ethereum, making micropayments viable. Governance models have evolved from token-weighted voting to quadratic voting, aiming to better capture stakeholder preferences and mitigate majority dominance. The broader adoption of decentralized identity systems, such as the Sovereign Network and IOTA Identity, also demonstrates a trend toward trustless, self-sovereign identity management that can integrate with autonomous vehicle fleets and smart city infrastructure. Chapter 3: Real-World APPLICTONS. Industry use cases. Manufacturing has embraced AI-driven predictive maintenance, reducing machine downtime by 30% and cutting maintenance costs by 25% across global automotive plants. In healthcare, AI diagnostic tools now supplement radiologists, detecting lung cancer with 89% sensitivity in low-dose CT scans, while oncology firms use genomics-driven AI to design personalized treatment plans. The finance sector applies algorithmic trading powered by reinforcement learning to optimize portfolios, and banks employ fraud detection AI that reduces false positives by 40%. Quantum computing has found niche applications in protein folding, enabling pharmaceutical companies to model drug interactions at a speed 100 times faster than classical simulations, thus accelerating drug discovery pipelines. Autonomous vehicles and transportation. The last year has seen pilot projects where Level 4 autonomous taxis operate in downtown Chicago, routing passengers with a 99.7% on-time rate. Commercial drone fleets are now delivering medical supplies across rural counties, cutting delivery times from hours to minutes. Shipping companies experiment with autonomous, self-steering barges on the Mississippi River, reducing fuel consumption by 15% and crew hours by 90%. In the logistics sector, autonomous forklifts and AGVs, automated guided vehicles, operate around the clock in warehouses, delivering a 35% increase in throughput. The integration of cloud-based real-time traffic data feeds, AI-driven route optimization, and vehicle-to-everything (V2X) protocols is essential for these systems' safety and efficiency. Smart cities and infrastructure. Energy grids are becoming smarter through AI adaptive load balancing, ensuring renewable energy from solar and wind can be integrated with minimal curtailment. In Singapore, smart street lighting now uses reinforcement learning to adjust brightness based on pedestrian density, saving 22% on electricity bills annually. Municipalities in Barcelona employ digital twins, cloud-hosted 3D simulations of city infrastructure, to anticipate maintenance needs and plan urban development, while autonomous public transport vehicles reduce congestion and emissions. Data collected from IoT sensors on bridges and roads undergo real-time analysis to predict structural weaknesses before they become critical, saving billions in potential disaster costs. Social and economic impacts. Collectively, these applications have created fresh job categories such as AI ethics officers, quantum software engineers, and blockchain compliance analysts, contributing to global GDP growth at rates of 1.2% annually in 2023. However, there is an increasing need for digital upskilling and reskilling programs. By 2024, over 30% of the global workforce is predicted to require some form of AI literacy. On the societal front, autonomous vehicles promise to improve mobility for older adults, while AI-driven education platforms personalize learning, reducing gaps in education outcomes. Yet, the rapid pace of change also fuels concerns about inequitable access. Ensuring that underserved communities also reap the benefits of these technologies remains a top priority for policymakers. Chapter 4: CHLNGS and LIMITETONS. Technical hurdles. AI bias persists in both image and natural language models because training data inherit human prejudices. Recent studies show that even GPT-4 can produce gendered or racially skewed outputs when not carefully constrained. In quantum computing, hardware coherence times remain short, and error correction requires a large overhead, making near-term quantum advantage limited to highly specific problems. Cloud security has evolved into a major concern, with data breaches scaling with the number of distributed services. Ransomware attacks on distributed cloud platforms have increased by 35% in 2023. Meanwhile, blockchain scalability remains a bottleneck. Even with Layer 2 solutions, high contention periods during token sales can spike transaction processing times. Adoption barriers. Legacy infrastructure costs are a significant obstacle. Many enterprises still rely on monolithic mainframes that cannot natively run AI or quantum workloads. Transitioning to cloud-native architectures demands a cultural shift and investment in DevOps practices that are often absent. The talent shortage for quantum programmers, which is only a few thousand strong worldwide, restricts the pace of adoption. Autonomous vehicle deployment faces logistical hurdles, such as lack of dedicated lanes, uneven sensor coverage in rural areas, and the complexity of integrating with existing traffic management systems. Exploring more technological innovations.